Hello students, now I'm going to teach you the most important theorem of the chapter similarity of 10th standard, that is basic proportionality theorem. In short we call it as a BPT. So the statement of the theorem is, if a line parallel to a side of a triangle and intersect the remaining sides in two distinct points, then the line divides the side in the same proportion. So what is the meaning of this one? So this one is a triangle, and this line AB, divides this triangle into two distinct points, that is A and B. The sides of the triangles are XY and XZ. If this line divides, or if this line intersects these sides into distinct points, that is A and B, then this line divides the side in the same proportion. Means what? This portion, that is XA upon AY and XB upon BZ. So these two parts are same. Means XA upon AY is equals to XB upon BZ. So see what is given. So here given that is in triangle XYZ, AB is parallel to YZ. Remember that in BPT you have already given that is one side is parallel to the one side of the triangle. This line is parallel to one side of the triangle, means AB is parallel to YZ, and it intersects line X side XY and XZ into distinct point, that is A and B respectively, such that X dash A dash Y, means A is in between X and Y and B is in between X and Z. So what is we have to prove? That is XA upon AY is equals to XB upon BZ. Now there is a construction, that is we have to join this AZ and a BY. So this is the construction in this theorem. Now see what is the first statement. So you have seen that is there are two triangles, that is XAB, see in figure XAB, and the second one is BAY. Look at the triangles XAB and BAY. Now see, you can easily see that is both the triangles having the same height, that is AB. And you learn in the first concept of this chapter, that is the triangles having equal heights, they are proportional to their bases. So XA upon AY, it is the answer. So area of triangle XAB upon area of triangle BAY is equals to XA upon AY. What is the reason? That is the triangles of equal heights. Similarly, we can see the another two triangles, that is XAB and next one is the ABZ. See again XAB and ABZ. Again these two triangles having same height, that is AB. Since they are having equal heights, so the ratio of area of these two triangles is in proportion of the bases, that is XB upon BZ. So area of triangle XAB upon area of triangle ABZ is equals to XB upon BZ. Again the reason is area of equal, that is triangles of equal heights. Now see these two triangles, that is triangle BAY and ABZ. First look at these two statements. In the first statement, this numerator part, that is XAB, and this one, both parts are same. If we prove that these two triangles are also same, then left hand side of these two statements becomes same, and then we can easily prove that the right sides are also equal. So first we are going to prove that BAY, area of BAY and area of ABZ are also equal. So see BAY, so BAY, this is the triangle, and the second one is A, B and Z. Now look at these two triangles. So both the triangles are in the located in the parallel lines, and you know that is the distance between the two parallel lines is same. So height of these two triangles are same. And now see, the base of these two triangles are also same, that is AB is the base of both the triangles. Means these two triangles are having equal height and equal base, so their areas are equal. And so we can directly write here, that is area of triangle BAY is equals to area of triangle ABZ. Why? Because these triangles are having equal heights and equal bases. So these denominators are also become equals, means both these left sides of statement 1 and 2 are equal. So the fourth statement, that is this part, is equals to this part, since we prove that these two triangles having equal areas. And the reason for this one is that is from statement number 1, 2 and 3. And since these left sides of statement 1 and 2 are same, the right sides are also same. That is, so we can easily write that this xa upon ay is equals to xb upon bz. And this we get from the statement 1, 2 and 4. Because in first statement we prove that these two parts are same. And so these two parts are same. And hence we prove that xa upon ay is equals to xb upon bz. So this is the most important theorem of the standard 10th, that is a basic proportionality theorem, or it is also called as a BPT. Now we are going to see the converse of BPT. The theorem is not asked in your exam, बस हमें सिर्फ इसका जो statement है वो देखना है. If a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. Means if you are given that is in triangle PQR, these ratios, that is px upon xq is equals to py upon yr, then we can easily say that xy is parallel to qr. So this is the converse of BPT. I repeat it. In triangle PQR, if I are given that is these ratios are equal, that is px upon xq is equals to py upon yr, then xy is parallel to qr. So this is the converse of the BPT. And what BPT says? If AB is parallel to YZ, then XA upon AY is equals to XB upon BZ. Now the next theorem, that is property of an angle bisector of a triangle. So what is the statement? The bisector of the angle of triangle divides the side opposite to the angle in the ratio of the remaining sides. Means what? So see in this triangle, see the triangle PQR. So this one is the given triangle, and QS is the angle bisector. You are given these two angles are same, means QS is the angle bisector. So what is the theorem says that if PQ upon QR, see the sides which make this angle, if these two sides, that is PQ upon QR, is equals to PS upon SR. So you have to prove that PQ upon QR is equals to PS upon SR. So what we are given? So in triangle PQR, see here, in triangle PQR, the bisector of the angle PQR. So bisector means it is QS is the bisector. It intersects the PR at point S such that P dash S dash R, and we have to prove that, see again, PQ upon QR is equals to PS upon SR. So what is the construction? So here we draw the MR. So we have to draw this line parallel to this QS, and now we have to extend this PQ up to M such that P dash Q dash M. QS and QS and MR, these are parallel lines, and we have to extend this PQ up to M such that P dash Q dash M. Now see statement, first statement. So in triangle PMR, see the triangle PMR, we are already given in the construction that is QS is a parallel to MR. Remember, whenever you are given that is one line is parallel to the one side of the triangle, you have to remember about the BPT theorem. So since we are given that is QS is parallel to MR, the ratio of these two parts, that is PQ upon QM, is equals to PS upon SR. So see, PQ upon QM is equals to PS upon SR. So this is from BPT and from 1, because in first time statement we written that is in triangle PMR, QS is a parallel to MR. So it is given in the construction, so we write the reason here, construction, and the second statement by BPT. Now see, QS is a parallel to MR. See here, QS is a parallel to MR, and if PM is the transversal. Now see, PM is the transversal. So these two lines we are given, first and second, and the PM is the transversal. So it is given, then what we can write? That is angle PQS is congruent with the angle QMR. See here QMR. See here angle PQS is congruent with the angle QMR. So which type of angles these are? So these are the corresponding angles. So the reason is corresponding angle. Again the same, that is QS is parallel to MR, and now QR is the transversal. See here QR is the transversal. These two lines are parallel, that is QS and MR are parallel, and since QR is the transversal, you can easily see the alternate angles. So these angles are congruent. So angle SQR is congruent with the angle QRM. Angle SQR is congruent with the angle QRM. So these are the alternate angles. But in the example or in the statement you are given that these two angles are congruent, that is angle PQS is congruent with SQR or RQS, because this one is the bisector, angle bisector QS, so these two angles are congruent. And so in triangle QRM, look at the triangle QRM. So in triangle QRM, we already proved that this angle and this angle is congruent. So see, QMR is congruent with angle QRM from 3, 4, 5. So QMR, see here QMR and QRM. Why? Because these two angles are congruent, so these two angles are congruent. So it is from 3, 4, 5. And since these two angles are congruent, these sides are also congruent because of the converse of isosceles triangle. So we can prove that is QM is congruent with QR. So QM is congruent with QR because it is the converse of isosceles triangle theorem. And now we have to put down this value in this statement. So PQ upon QM is equals to PS upon SR. But here we prove that QM is congruent with QR. So we have to just remove this QM from this and put QR. So we get that is PQ upon QR. See here PQ upon QR is equals to PS upon SR is as it is. It is from 2 and 7. And hence we prove that PQ upon QR is equals to PS upon SR. That is PQ upon QR is equals to PS upon SR. Next, the converse of angle bisector theorem. So here we already proved that if we take the ratio of this, that is PQ upon PR, then it is equals to the QS upon SR. So in the converse, if you are given that these ratios are equal, then PS is the bisector of the angle QPR. So this is the converse. So see, in triangle PQR, ray PS intersects side QR at point S such that Q dash S dash R. And if PQ upon PR is equals to QS upon SR, then ray PS is the bisector of angle QPR. Means अगर हमें ये दिया है कि ये दो रेशो means PQ upon PR is equals to QS upon SR, then PS will become the bisector of this angle. Next, the property of three parallel lines and its transversal. So see, the ratio of the intercept made on the transversal by three parallel lines is equals to the ratio of corresponding intercepts made on any other transversal by the same parallel lines. So what actually we have to prove? Means if you are given that is three parallel lines, so A is parallel to B is parallel to C, means line A is parallel to line B is parallel to line C, and if these are the transversal, P and Q are the transversal, where P intersects these lines A, B, C at point L, M, N, and Q intersect the same lines at point X, Y, Z. So this is given, and what we have to prove, that is we have to prove that intercept. So what is the meaning of intercept? So the portion in between these two means LM, so this portion, MN, this portion, so these are the intercepts. Here also XY and YZ, so these are the intercepts. So we have to prove that LM upon MN is equals to XY upon YZ. So this is to prove here LM upon MN is equals to XY upon YZ. So what is the construction? You have to draw the line LZ which intersects this MY at point K such that L dash K dash Z. Now see how we can prove this one. Now see in triangle L and Z. See L, N and Z. So in this triangle MK is parallel to NZ. Since the three lines are parallel means this is given in your example, so the reason is given. Now if this line is parallel to this line means in triangle one line is parallel to the one side of the triangle, then these ratios are same by the BPT, that is LM upon MN. LM upon MN is equals to LK upon KZ. See here LK upon KZ. So this one is by BPT. Now we're going to see the another triangle LZX. See here LZX. Here also KY is parallel to LX. This is given. KY is parallel to LX which is given. And again by BPT we can prove that LK upon KZ is equals to XY upon YZ. If you take the first part, this one, that is LK, then here you have to take XY. LK upon KZ is equals to XY upon YZ. LK upon KZ is equals to XY upon YZ. So this one is by BPT. And since see these two ratios, so which one is common? LK upon KZ is common in these two ratios. So these parts are also equal. So we can write that is LM upon MN is equals to XY upon YZ. So this is we have to prove. So this is all about the property of three parallel lines and its transversal. So the next concept we will see in the next lecture. Thanks.